At Frewer Engineering, we specialize in a range of finite element analysis requirements with particular expertise in composite materials. In this video, we'll take you through how we use FEA to analyze and predict composite material failures. For this example, the focus is on the structural integrity of a drone under simulated operational loads. The setup involves applying aerodynamic loading to evaluate the behavior of the composite components. To predict failure, we initially employ methods such as Hoffman, Saiwu, and Tsai-Hill failure criteria, each with slightly different benefit. Saiwu accounts for the interaction between stress components. Hoffman builds on Saiwu, distinguishing between tensile and compressive strengths. Tsai-Hill provides a simpler, quicker assessment, though it is often more conservative. As shown in the analysis, all three criteria delivered comparable results, with the highest failure indices occurring near the corners of the fuselage rings. And as predicted, the Tsai-Hill Criterion yielded the most conservative predictions. Moving beyond these approaches, our team is experienced in advanced failure theories like the Hashine and Puck criteria. These methods help distinguish between failure modes such as fiber breakage, matrix cracking, and delamination, while providing insight into the progression of damage in complex composite structures. For more information about our capabilities in FEA and composites, visit our website or connect with us on LinkedIn.